That is good. That is very good. So who can lead us in short prayers and then we start our lesson, please? Who can lead us in short prayers? Letitia?
Yes, teacher.
Letitia, lead us in short prayers and we start our lesson, please.
Okay. In the name of the Father, and of the Son, and of the Holy Spirit.
Amen.
Amen.
And Lord, thank you for enabling us enter this lesson today. Enable us understand whatever teacher is going to teach us. Guide the teacher, teach us the right things, and enable us to understand. In Jesus' name I pray, amen.
Amen. Okay, Letitia. Okay, Letitia. Okay. That is good. So members.
Yes, teacher.
The last time we met, we were looking at antilog. How we get anti-logarithm. Anti what? Anti-logarithm. We said anti. This time, if you are talking of anti-logarithm, is we are getting the number when they have given the log. This time, the log of a given number. The log of a given what? A given number. So we are moving backwards. So they will give you the log, then they want us now to move back and get the number. That process is what we call the antilog. That process is what we call the what? The antilog. But when you are reading the antilog, we have two different type of tables for logarithm. We have what we call the logarithm, which is reading the log of a given number, then the table for the antilog. The table for the what? Antilog. So let me add for it here. Let me search for it here so that we can also have both of them. We just look at it very fast. Good. I think we are able to see it. Are we able to see it there?
Yes.
Members, are you able to see it?
Yes.
Or I enlarge it a bit. I make it big a bit.
It's okay.
That's how it's okay. Oh, okay. All right. Now, so we shall use antilog table, or we can also use our calculator, or we can also use our what? Our calculator. So from our calculator, if you want to find the antilog, we press shift and then log. It must display for you. When you see this one means is what? Is the antilog. Are you together, member?
Yes.
Yes. So you press shift, then log, then it will display for you that. That's if you are using a calculator. So I've already taken you through that. But we said, members, when you look at our log table, our log what? Our log table, there is no logarithm that is beyond 1. Have you seen logarithm that is beyond 1? It's not there, not so. It's not what? There. So when you look, take for example, I have log, let's say log of 3.25. Let's press that one from our calculator. Let's press it. Log of 3.25. You find that we get 0. What? 511 what? 19. So this one, we said it must be to how many decimal places? To 4 decimal places. You see that even if the number is big like what? The logarithm of that number is always in the range of 1. It's the range of 0 point something. Logarithms are in 0 point. 0 what? 0 point. But when, take for example, now like this one we have, when you see that, I said the first number here before a number before a decimal point in logarithm is called what? So like 0.5119. This number is called what? That number is called what? It's called what?
Characteristic.
Then this one is called what? This one is called man what? Mantista. Then this one is called what? What is this one? This one is called what? 3.2 is called what? 3.25 is called what? Who can remember? It's called what? 3.25 is called what? This one. It's called what? It's called what?
Argument.
It's called argument. So if I read log to base 10 of 3.225, This one is what we call the argument. This one is called the what? The base. So members, so when you are getting the antilog, when you see that the number here, the characteristic, if the characteristic is a non-zero, if the characteristic, if the what? If the characteristic is a non-what? Is a non-zero, then first express the log, to the powers of what? Of 10.
Of 10.
Of 10. Now, like the other one, the one I gave the other time, which the question was, the log was 4.3142. Do you remember this? They want us to find the antilog of this, So this is the log. So you find that this one is to the power of 4, which means this number, there's no log which is to the power of 4. There's no negative logarithm. There's no negative what? Logarithm. So which means this one is a what? Is the what? Negative 4 is what? Is the characteristic. Negative 4 is the what? So which means this one is the same as, because we can write this one as, is the same as 10, is the same as 10 to the power 0.3142 times 10 to the power negative what? Negative 4. So which means when I write like this one means I'm getting the antilog. This one means I'm getting the what? The antilog. Because I've already removed this negative, which is the characteristic. So I'm going to get the only what? The what? The Manchester. So we go to our table. Let's go to our table. Our log table is here. So members, we are going to read. We are going to what? We are going to read log of 0.3142. I think that, members. I mean, we are going to read the antilog of that. Sorry, the antilog. Take note. We are going to read the antilog of 0.3142. So you come to your table, you read. Let me write it here. So read. The number is 0.3142. So we are going to read 0.31 under what, members? Under what? Under 4. Then we add what? Then we add what? We add 2. So let's go to our table here, the antilog table. We read 0.31. 0.31. Members, are you seeing it there? We have 0.31 here. Are you seeing where my cursor is?
Yes.
Members, are you seeing it?
Yes.
0.31, 0.31 under 4. Under 4. 4 is here. Are you seeing 4 there? You follow it from there. You follow it well. This is 0, 1, 2, 3, 4 is here. I think that. Members, have you seen that?
Yes,
So
teacher.
the number is what? The number is 2.06 what? 0.61. What are we adding? We are adding what? We are adding 2. We are adding what? 2. So you come here. I think where they are saying add 1, 2. I think there.
Yeah.
Let's come back here. The number is here. Our number is here. We are adding. We are adding 1. We are adding 2. 2 is here. So under 2 is what? Under 2 is what?
1.
1. So which means that number is, so it's going to be plus 0.00. 00 what?
1.
So what is that number? The number is it. So this is it.
2.062.
2. I think that.
Yes.
So which means what is our antilog now? The antilog, remember there the other time we wrote 10 to the power 0.3142 times 10 to the power negative what? Negative what? Negative 4.
Negative 4.
So this one we have got the antilog. The antilog is what? So which means the number becomes is 2.062 times 10 to the power negative what?
Negative 4.
So that's the number. So this is the what? This is the what?
The number.
Members, have you seen that?
Yes.
Let's give one more example on that, and then we move to the next one. Let's move to the next one. Like which question? Check under the exercise here. Which question should we do? Let's look at question 8. I think question 8. I mean question 5. Let's look at 5. Number 9. Number 9. Sorry. Let's look at question number 9. The antilog. The what? The antilog of what? 5.301.
0.
So which means we are going to say 5.3010 is equals to 10. I think that we remove this 5. We say this 5 is the what? This 5 is the what? It's called what? The characteristic. So which means you're going to be 10. We take that 5 away. 0.3010 times 10 to the power what? The power here is the power is a positive, which means it's going to be to the power what? To the power 5. Now we go to our antilog. We read what? So read what? 0.3 what? 0 under what? Under what, members? Under what? Under 1. Then add what? Members, have you seen that?
Yes.
Let's go back to our antilog here. The number is, let's look for 0.30. I think it there. I think where my cursor is.
Yes.
The number is under what? 0.30 under 1. Under 1. Let's check for under 1. Under 1 is there. This is 0, 1. What is the number? Members, have you seen the number?
Yes.
The number is what? 2.000. What are we adding? We are adding what? We are adding 0. We are adding 0. So you come, I think 0, there is no 0 there. So which means that number will remain like that. Have you seen that, members? So which means, so the antilog, the number is equals to, we have got the antilog of that, which is 2.000 times 10 to the power what?
The power 5.
Members, have you seen that?
Yes.
Now, if you are using a calculator, let's work it with a calculator. Let's work with the calculator. So with a calculator, you first split it like we have done here, because there's no calculator which is going to give us a logarithm of numbers which are beyond 1. I think that is 0 point. Our all logarithm are 0 point. Are you together?
Yes.
So now I want to find the antilog. So you press shift antilog. Open a bracket of what? 0.301 what? 0. Have you seen that? Close the bracket. What is the number? Have you seen that? Members, have you seen that?
Yes.
So when you round that one, what do you get? You get 2, not so? When you round that one, it's not true that you get 2.
Yes. It's
Now, this is where I get people who are using a table or a calculator, because sometimes when I'm setting exams, or when the examiner is setting exam, will limit you. The examiner will say using the log table. Using the log what?
table.
Someone who have used a log table must get what? Must get what? Must get 2.
This.
But if you have used a calculator, you will get what? 1.9998. Members, have you seen that?
Yes.
Yes.
Good. Let's look at this one. Let's look at this one. Shift antilog of the number is what? 0.3142. Close the bracket. Is not what we have here? Members, is not what we have here?
Yes.
Is the 1, not so?
Yes.
Yes. So
Teacher.
yes, please.
So how do you determine that negative 4? I've not understood that part because last time I did attend.
The
That
negative, the negative, that is the logarithm. Because remember, we said when we are getting the logarithm, we have seen our logarithm must be less than 1. The number must be less than 10. The number must be less than what? 10. We have seen how to get logarithm. We said when you have a log, when you have a given number and you want to determine logarithm, when the number is greater than 10, when the number is greater than what? What do you do? What do we do? What do you do? We said we first what? If the number is greater than 10, greater than what? 10, you first change the number to the what? You first express the number in standard what?
Standard form.
If the number is less than, if the number is between 0 and what? And 1. What do you do? You also express the number in standard what?
Standard form.
In standard form. But if the number is between, the number is what? Between 0 and what? Between 0 and what? And 10. 0 and 10. This one you get it logarithm direct because what we have in the log table that in the all, that's why you see when you look at our log table, is ranging from 0.0, 0 what? 0 up to 9.99. Have you seen that? That is from the log table. This is log table. Log what?
Table.
Log table. So which means when we want to get a logarithm, the number that is if the number is greater than 10, the first step is to express it in standard form. Why do we do it? Why do we do it like that? So that the number that we are going to get, because our log table give only logarithm for numbers which are between 0 and what? 0 and what?
0 and 10.
0 and 10. That's why we have first to, that's the reason why we have first to express it in standard form members. Okay?
Yes.
Now, to answer that question, where someone said, where's the negative coming from? We remember when we are introducing logarithm, we first learned standard form, scientific notation. Do you remember that?
Yes.
We said if the number is less than 1, take example, you have a number which is 0.425, and they are telling you to express this number in standard form. You find that the power will be what? A negative power. Not so?
Yes.
What is this one in standard form? What is this one in standard form? It's going to be 4.2 what?
5
times 10. How many times have you shifted the decimal point? You have shifted it what? Once. So which means to the power negative?
-1.
-1. Patricia, have you seen? Is it Patricia or someone was asking that question?
Yeah, I've seen.
You have seen where the negative is coming from.
Sure, the problem is this number that is saying 4.3142.
Let's do another one with a negative power. Let's do another one with negative power. I see number 11. Can we do number 11 or number 8 or number 5? Which one should we do? Let's look
11.
at the one with number 11. Question number 11. Question number what? They want us to find the antilog of what? 1 bar. We said for logarithm, when the number is a negative, you don't write it like any ordinary number. You don't write it -1. You don't write it like that. You write 1 bar. Are you together, Patricia? And the negative is only for the characteristic. The negative is only for the what?
Characteristic.
Not the mantis term. So we have 1 point, we have 5, 7, 5 what? 5, 2. So we are going to say 1 bar 5, 7, 5, 2 is the same as 10 to the power what? So we remove this negative. So they become 0 point. I think that 0.5, 7, 5 what? 5, 2 times the 10 to the power negative what? -1, which is this power, which is this one. Have you seen that?
Yes.
Yes. Now we go to our log table. We go to our anti-log table. Then we read for the anti-log of 0 what? 7.
0.5752.
How do you read? So we are going to read 0 point. You take the 2 decimal places. We take 2 decimal places. 0 0.57 under what? Under 5.
Under 5.
Then we add. Then add what? Add what?
Add 2.
Let's go back to our anti-log here. The number is 0 point. Oh, our log table here is ending in 0.50. Okay?
Yes.
So let's use the calculator now. Let's use calculator for that. But the one they will give for UNEP, it has everything. For UNEP has what? Everything. This one, yes. So let's use calculator for this. So shift anti-log. Shift anti-log. Yes?
In UNEP, do they give us the logarithm table?
The log table is there. They will give you. The table is there. They will always, that book is there, okay?
Okay.
Yes. Anti-log of 0 0.5752. What? 2. What do you get? The number is what? So it which means it becomes 3.760. We can put it like that. Times the 10 to the power what? Negative?
Negative 1.
Negative 1. So that's the number. That is the what?
The number.
Members, is there any question? Who doesn't know how to? By this time we must all know how to use a calculator, and we must be able to also to use a log table. Okay?
Yes.
If you want to find the anti-logarithm, you use the anti-log table. If you want to find the logarithm of the number, you use the log table of that number. Are you together?
Yes.
Please ask me before we proceed. Am I loud and clear on that? Am I loud and clear on that, members?
Yes.
Thank you. Thank you. Now, members.
Yes.
Now, today, let's look at application of logarithms. Subheading, application of logarithms. Application of what? Logarithms. Applications of logarithms. Members, what we have learned, we are going to summarize them in a very simple form, in a very simple what? In a very simple form, using what we call the anti-log, using what we call the logarithm, using what we call the what? The logarithm. So we said the main use of logarithm. So right, the main use or the main application, the main application or use of logarithm is in the multiplication and division of what? Of numbers. Of what? Numbers. Full stop. It can also be used. It can also be used in finding or evaluating. In finding or evaluating roots of numbers. Root of what? Numbers. Root of what? Numbers. Members, are we together?
Yes.
Good. Now, For us to understand that one, to understand the application of logarithm very well, because we said logarithm can help us to simplify numbers in under multiplication and under what? Division. Under what? Division. Now, for us to understand that one better, there must be some rules or laws that govern that. Okay?
Yes.
So let's look at rules or laws of logarithms. Whenever we are going to talk about logarithm members, what we have learned in other sessions, that one we are just looking how to apply those laws. But now we want to see what are those laws. There are some of them which we have already talked about. Okay?
Yes.
Let's look at one by one. Law number one. There's what we call addition or to product law. Addition to product what?
Product law.
What does it state? It states that if I have log to base A of B, okay? Plus log to base A of C, the answer we get must be log of A of what? B of B what? BC. That law is called what? Addition or product rule. Product means multiplication. Product means what?
Multiplication.
And the way we have written it, it means the reverse is also true. The reverse is also what? True. It means if you are multiplying numbers, you can simplify that number by what? By adding them. And if you are adding them, you can simply what? Multiply them. That is law number one. That is law number one. Members, are we together on that?
Yes.
Very good. Number two, what we call the subtraction to quotient. Members, when I talk of quotient, I'm meaning division. Quotient means what? Division law. What does that law state? That law states if I have log of A, I'm going to use the same logarithms. If I have log of A of B, to base A of B, take away log of A of what? Of C. That law permits us to write it as log as a single logarithm of A of B over what? B over what? B over C. That law is called what? Subtraction to quotient law or to division law. Members, are we together?
Yes.
Yes. And the reverse is also what? And the reverse is it? Is it true?
Also the same.
Number three. What we call the power law. Now, if I have that law states that if I have log to base A of B to the power M, to the power what? M. That law permits us to bring the power. I remember when I was introducing logarithm, according to John Napier, where he said this number can be brought to the in front, not so?
Yes.
Then he said this number can be written as M log of B of what? Members, what have you discovered? What have you discovered in the first three laws? What have you discovered? What have you discovered? For us to deal with, for this law to be applied, for this law to be what? Applied, then they must have the same what?
Base.
They must have the same base. So we have just few seconds remaining. So when we come back, we shall continue from there. Members, let's join immediately. Let's not delay. Okay. Yes. So that is the power law. So when we come back, we shall look at the fourth one. Good, 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 good. So the fourth one, we shall look at it when we come from the